Hi, I'm Edward Gilbert with Gilbert Fab, or Gilbert and Company Inc. And this is my remote inspection of the part 0090DDB from job J000EA3F. So, anyway, I wasn't familiar with this remote inspection thing because this is only my second job, but once I learned what it was all about, it's pretty cool. So anyway, we're a small job shop, and the tools that we have here for doing inspections are not super high tech, but we have decent tools. This is my Mitio caliper, 6-inch caliper. It's accurate to a thousandth of an inch. And as far as for the hole diameter, I've ordered some pin gauges, but they're not here yet. I ordered them after I started taking Xometry jobs. So what I've been actually doing is using wire gauge drill bits and then measuring them to make sure that they're at the same size that they're supposed to be. So all the holes on this part are the same size, and the size is 98 thousandths. So if I take my caliper on this tool, you can see the drill bit is 98 thousandths even if I rotate it. So this should be a decent gauge for the holes. And as far as the countersinks, they're supposed to be at 100 degrees. So I always verify that the tool that we're using is at the angle. So this is the tool we use to do that countersink. It has a 100-degree angle, a 1/4-inch tool, so that would make sure that the angle's right. So we just would need to verify the diameter of the at the top of the surface. And I've transposed some of the information from the list. I've numbered the part locations, and then I've started a sheet already to make it easy. So let's jump into this. I'm gonna need my calculator at some point, so I will clear everything out of the way. So the first measurement, it looks like, is going to be the height of the part. And it says the height is supposed to be 425 thousandths. So if we check it, we're going to have 429 thousandths. So we're 429 thousandths, which is 4 thousandths over, but we have a 5 thousandths tolerance, so that passes. The next measurement is the distance across from here to here. And according to the drawing, it should be 1 inch and 580 thousandths. It's a little tricky doing this, holding the caliper in the air. But as you can see, we're 1 inch and 580 thousandths is right where we need to be, and that's right on the money. So let's mark that to be 1.580 and then give that a pass. So the next measurement it's asking for is the distance on this little arm here. So the distance from here to here, and that's supposed to be 200 thousandths. So we'll take our caliber and we're going to check this at 199 thousandths. That's pretty darn good. So we're only 1 thousandths off. So the measured is 0.199. That gets a pass. Measurement 4 is going to be the height of the thing. This one's tricky to do, holding this where the camera can see it, but we'll do it. So we're looking for 1.29. Actually, let's make sure we're starting at 0. Come down on the part, nice as square as we can. So we're at 1.2865. 1.2865, which is only 3.5 thousandths smaller, which within the parameter because we have the 5 thousandths tolerance. So we're good there. And then we're on number 5, which needs the measurement. It looks like number 5 is the measurement of the thickness of the raised part here, or that whole thing, I guess, right? And it needs to be 265 thousandths. So we'll get that at 261.5, 262 thousandths, and we need a 265, so we're good there. So we are at 0.262, so that gets a pass. And the next is the distance, the width of the part. So it wants to know from across here. So we can do that. So make sure we're set at 0 again. And make sure we're nice and square here. The distance we're looking for is 2 inches and 240 thousandths. And we're at 2 inches, 241.5 thousandths. So that is on the money. 2 inches, 2415, that gets a pass. Now we're down to the holes. So in the holes, I already demonstrated the size of the drill bit, so we just need to make sure that it fits through. So the first one is just this hole here by itself. And so we get that through there, and it's a nice tight fit. So that's good. And then on the other holes, they're all the same diameter, except they have the countersink. Yeah, so it fits through all those holes. So that part's good. So now the countersink. So the way I've been verifying the diameter of the countersink is a little different because I don't really have the best tools for doing it, but it says that it's 180 thousandths. So what I do is I'll take my caliper to 180 thousandths. Let's get it as close as we can to there. That's good. And then I'm going to lock it, right? So we're 180 thousandths. And then I'm going to take my magnifying glass. So now I'm going to take my magnifying glass and look at this, the biggest I can, and get on the 2 highest points. And that seems to be right on the money. Same with that one. Same with that one. So I would say that that hole passes because it's the right diameter and the countersink is the right diameter. So both that hole there and the 3 countersunk holes all pass. So I'm going to put exact, I guess, because I don't know what else to put in there. So there's one last measurement, and the measurement is going to be, it looks like the width of this opening. This was a tricky little deal here because this has an angle to it. So in order to get that shape, I had to do 3D contouring in here so it would slope down. I did a 3D plane and pocketed out and everything. So the measurement we're expecting across there is 0.405 or 405 thousandths. So let's unlock this. set this to make sure it's on 0 and lay as flat as we can here. And we're at 406.5 thousandths. And that's a pass. So I don't know, we're not normally a shop that does really technical inspections and stuff, so this is a learning process for us, and I feel that we've done a pretty decent job of getting this part as accurate as possible. And as we move forward and build a relationship with Xometry, we will also improve our techniques in doing inspections and get better equipment for doing it. And I hope that you find that what we did here was adequate for these parts. But just to give you a rundown, that these parts were done in a series of 10 per cycle. So on the original inspection sheets, which will also be included with this, I would inspect the first one and then quickly check the other 9 to make sure that they conformed with the first one, because in most cases, if the first one in a series of parts is accurate, the rest of them should follow suit. And then I've bundled them really nice and neat with marking which batch they were in. So this was batch 1, batch 2, batch 3, batch 4, and then the one we have tore apart here is batch 5. And the inspection sheets would reflect one for each one of the batches. So anyway, that's that. Edward Gilbert signing out.